So this morning I'll be talking about the future of Java Standard Edition. When I talk about the future, plans subject to change, so not a promise. About myself, my name is Aurelio Garcia Ribeiro. I'm a director of product management with the Java Platform Group with Oracle. I've been with Oracle and previously with Sun since 2008. Before joining Oracle, I worked at Sun Microsystems, as I said. And before that, I got an MBA from MIT and a bachelor's degree in systems engineering. Now, part of my job at Oracle is to make sure that other products that rely on Java are not surprised by any of the changes that we're putting into the platform, and that they're aware of what we're doing. And I figured that's something useful for everybody here, not just for the people within Oracle. So first question before we start, who here is a Java developer? Fantastic, the majority, so I hope you'll appreciate this. What is the latest version of Java available right now? 11, 12, fantastic. It's 11, 12 is coming out later this month, in a few days actually. Which version of Java are you developing with? Who's using Java 11? Okay, excellent. 10, 9, 8. Okay, that's expected. 7, 6, less than 6. 12? Anybody played around with the early access of 12? Good, you liked it? Good. So, what happens? We're trying to make Java more open. Java has been open source for many years, but at the beginning, open source meant we do the code in secret. When it's done, here it is. And we've been evolving that. Now we've reached the point where not just the coding, but also the planning, the decisions of the features, all of that is done in the open. Oracle does most of its work in the OpenJDK community. We're the lead for the OpenJDK community. We need to evolve the platform. And evolving the platform means adding new features, which is relatively straightforward. In some cases, changing how things work, which is extremely difficult because you people have built stuff that relies on how things work. And in some cases, even removing things, which is even harder, and we try to do the least amount of. We want to be nimble. We cannot afford to have these large gaps of multiple years between versions on which no new features are available. And we want to be scalable. We want to have the same JDK. Who here remembers the multiple editions? Anybody use Java ME? Micro edition, right? That was meant to be used on devices with constrained capabilities. But it always was lagging to the Java Standard Edition. And that's inconvenient because that meant that you needed to have different skill sets depending on which Java platform you wanted to target. Our goal is to have the same Java SE available at every level of the scale. So we've made things to make it possible for use Java SE on smaller devices, the same as on large servers, and everywhere in between. Is that terribly important nowadays for you guys? I imagine most of you don't intend to target Java in constrained devices, right? But who here uses Java on a container? Or plans to use Java in a container? There we go. So you probably want to cut down on the amount of stuff that's available on Java to only the things that you need on that particular application. So some of the improvements that we made will benefit you as well. Now, how do we get here? How do we go from JDK 8, only about a year and change ago, to about to reach the, like the launch of JDK 12? We changed the release model. We used to have a feature-driven model where a bunch of people sat down and agreed, okay, this is what's going to come out in the next version of Java, 3 years, 2 years down the pipe. And then we worked on it to a time bound. It's just going to be on a given time, and the features are the features that are ready whenever the release is ready. So we used to have, this is a theoretical model, right? Very pretty model, where we had, let me back up a little bit. We had a major release scheduled every 2 years with large number of changes. And we supported it for a very long time. So, this is pretty classical. Everybody developed knows this kind of little chart, right? Now, when the release was the current one, you notice that during these first 2 years, this release is the latest one. There's no other release, right? Only when it was the current one, we had what we called minor updates. So the idea was, you GA, you get a few minor updates, and then it becomes stable, and then it just gets, critical fixes. And then if you want new features, you're supposed to go to the next release, okay? Now this means that in theory, that gives us a release vehicle for new functionality every 6 months. So far so good, that's pretty reasonable. The problem of this is, who here has worked on a project that's scheduled to release? Yeah, thanks for the notice. If you could silence your phone, I'll do the same. I always wait for the first person to get that one. I'd appreciate that, thank you. So, who here has worked on a project that has a schedule to be released 2 years into the future or more? Any of you that have done that, how likely is it that you will actually hit that date? It never happens, because of course when you plan 2 years into the future, you never foresee all of the complications. So what really happens is, right, we had closer to 3 years between the release of Java 8 and Java 9. And that may not seem like a big deal. It's a major feature, we can all wait a little longer. But look what happened here. We have a year and change where we had new capabilities that were ready, but we didn't have a vehicle to deliver them. And that's extremely annoying for our users and for the Java developers that are writing the new version of the platform, right? You were set to go. You were ready here. And because some feature, Jigsaw in this case, was not ready, your feature has to wait another year. Not nice. So why don't we change that? We're going to have a feature release every 6 months. The problem with this is, you notice that we only change the version every so often. Now, the Java language has something called the Java specification, which calls out exactly what APIs are required for you to call something an implementation of Java. We can only rev the Java specification every time we rev a major release. So if we kept it like this, which is what some people wanted, we would have had to, hold some large changes to every other release or something. We said, no, we don't want these crazy restrictions. So this is what we're going to do. A new release every 6 months. Okay? There's no way we can support a new release every 6 months and then have this extend all the way to here, right? That doesn't work. Now, luckily, this problem has been solved by many others, so let's just copy their solution. Some of them are going to be long-term support. And the others, some people call them short-term or something. We just call them, those are the non-LTS releases. So, this should be familiar if you use Ubuntu, right? Who here is using 1804 LTS, whereas some people are already in 1810, right? Same deal. Now, the next question when you come up with this model is, how far apart will the LTSs be? And the answer is, we've been averaging with the major releases, a major release every 3 years. Remember that I said that we were aiming for 2? Yeah, we aim, but we don't always hit it. So on average, we've had sometimes as much as 5, sometimes 2, but we figure 3 years is what the industry is already well accustomed to if you're just looking for the long-term support options. So we've just released, the current version is an LTS 11, and the next version scheduled to be an LTS is 17, 3 years after 11. So far, so good? Excellent. Now this is not retroactive, so we're not gonna shorten the support timeline for any of the prior releases. Notice we're somewhere around here. So we've already reached end of life of JDK 6. And now we have available and alive 7 and 8. We have these strange things because now 9 and 10 are no longer supported. They're end of life. They're not getting any updates, not even security fixes, even though 11 is. But I guess we can all get used to that. I hope so. Now, this is like the nice flat theoretical model. Now let's talk about the licensing. We used to offer something called the Oracle JDK. which was based on OpenJDK, but layered things on top. We had additional functionality. We had commercial features. Now this is pretty standard. Most OpenJDK contributors grab the OpenJDK code and put some stuff on top of it. And we did the same. And therefore, Oracle JDK and OpenJDK were different. Okay? What's more, when people tell you, I use OpenJDK, I always challenge that. I say, you do? Really? You compile it yourself, right? Because OpenJDK is just source code. If you're using OpenJDK, you normally mean I'm using the binaries built from OpenJDK that are built by somebody else. I mean, there's some people that use OpenJDK, grab the source code and build it themselves, but that's very few. Now, we also had some licensing things. You could download the JDK under a license that we call the BCL, Binary Code License. Same license that Sun used for many years. Oracle just changed. Basically, we changed the name to say Oracle instead of Sun, and pretty much the rest remains the same. And that's how we offered 6, 7, and 8. Now, the way that worked was we would offer the current version under the BCL until the next version came out. Then we had about a year of overlap. So there was a year between 7 and 8. And after that, we said, okay, further updates to 7 are only available to customers. Everybody else should be on 8. Okay? So if we use the same logic, after 9, about a year after that, we should reach the end of life of 8, and everybody should be in the latest version. Now, 8 is the sunset release for a bunch of technologies. We've done a few changes that make the jump from 8 to after 8 slightly harder than the usual jump. So in acknowledgement to that, we've decided, you know what, we're going to give the public users a little bit more time to use 8. So we've done something that we hadn't done before. Normally we would have said, end of public updates of 8, further releases are going to be behind a password. Now we're saying they're going to be available for public use for another 2 years. And that should give everybody time to move away from the features that were only on 8 that didn't made it past 8. Okay? Now, something else that we started doing. With JDK 9, Oracle decided, okay, we're getting requests to provide a license that, for example, doesn't require a click-through. And we said, okay, we're going to give you OpenJDK binaries built by Oracle, tested by the exact same people that test the Oracle JDK. They're the same binary. The only difference is going to be the license. So these blue ones are the OpenJDK binaries by Oracle. And we're going to give them to you for every release. 9, 10, 11, 12, et cetera, et cetera. Now there's a catch here. Notice that the OpenJDK releases that we provide do not have an LTS component. So as before, the long-term support is from customers. If you do not want support, the latest release is always available. Another way of looking at this is OpenJDK, we offer a continuous stream, the latest release. Now, other vendors may offer long-term support as well. So if you want gratis availability of 11 after Oracle, you can go take a look and you'll find other vendors that provide it themselves as well. There's one little thing. Notice that 9, 10, and 11 here are slightly smaller. That's not because I cannot graph. That's because there were some commercial features that were available in JDK 8 that we decided we're going to make available. We want to close the gap. We don't want to have this distinction between the Oracle code and the OpenJDK code. And that means that some of the things that we had available only in Oracle JDK, we open sourced. I'm talking Java Flight Recorder, Java Mission Control, the CGC or ZGC garbage collector, application class data sharing. Other things that were available only in Oracle JDK, like a plugin for launching applets and WebStart, since that's no longer a common deployment model, we're just terminating on both. So that's what I meant with 8 is the sunset release for a few technologies. Okay? Now, what does that mean? We expect a large number of users will, instead of grab these one-size-fits-all binary from Oracle, they'll go to the OpenJDK binaries. And as I said, they're the same thing. There's still a few discrepancies. If you do a Java minus version, you can tell which one is which. The Oracle JDK, for example, behaves differently when you say compile to an older version, because we had some libraries that the OpenJDK didn't. But for all intents and purposes, they're the same thing. There's no difference in performance, functionality, or capabilities. Okay? So as soon as we said this, of course, there's a lot of, oh my God, you're going to produce a major release every 6 months. It's going to be horrible. Nobody will be able to keep up. And this is just, non-LTS releases are betas, right? And you only should look at the LTSs. Not quite. So of course, there's some people that say, no, it's every 6 months. It's much shorter. They're the same as the update releases. And there's this camp that says, it's update releases, and this one, no, it's like majors. They're not. It's neither one of those is right? So the pessimist, as I said, every feature release, each one of these 6 months, right, will be as disruptive as the old major ones. Remember, you had to go from 6 to 7, 7 to 8. Nobody will be able to keep up. Not really. So the old majors were about 2 years worth of very large features with hundreds of smaller features and bug fixes. Combination of 2 or 3 years of changes. The feature releases will have at most one medium-sized feature and perhaps 1 or 2 smaller ones. That's it. So it represents the last 6 months. Now, usually here somebody points out, does that mean that we're never going to have any more large features? Remember, right? One large feature, medium-sized features. What happens to the large features? The new model compels us to cut down the changes into smaller, more manageable changes. So instead of one massive improvement every 2 years or 3 years, you may get incremental improvements that over time add up to the equivalent. Okay? Okay, so the optimist will say, oh, they're like the old minor updates, and we didn't even notice that there were minor updates. So this is going to be simple, right? Also not correct. The feature releases can and do deprecate or remove features. We may change the list of supported operating systems. So, for example, we drop support for 32 bits. If you had some native libraries that require 32 bits, we could do something like that in any feature release. So it's not just not quite the same thing. We can change the specification. That was the whole point of giving them a new number. Some people said, why don't you just call them dot something? Because we want to be able to change things, okay? And in case you forgot, the minor releases did break some people, probably didn't break you, and that's why you think they're, like non-entities, but it happened. So in reality, most feature releases, trivial to update. I saw a few hands that said that you were using 11. Any of you started using 9 or 10 before? Does anybody migrate from 9 to 10? Okay, we've got a bunch of open source libraries that we have to keep our eyes on. And we've noticed that going from 8 to 9 took some time. But once they've made that jump, keeping up with 10 and 11 has been relatively straightforward, right? Everybody goes with a lot of trepidation. Oh, this is going to be scary. Nah, not a big deal. Once in a while, a feature release might require that you change some code. So that's, it's likely to happen. But just to be clear, it won't be the same feature release for all programs. So if you are working with memory management, when we throw in some changes from Valhalla, you may need to change some code, but everybody else will be fine, right? So it depends on what your program does, what is going to be your next disruptive update. And we have new tools. I'll talk about this in a few, later in the presentation. JDEPs, JDEPRScan, and new processes to minimize the surprises, as long as you don't skip a few releases. So of course, some people may choose to say, I'm just going to look at the LTS releases. Then all that I said about the warnings that we're going to give you, all of that goes out the window because you're going to miss the warnings that will happen between LTS releases. So in reality, the new model, the feature releases, are closer to the update releases than the major ones. Some of them will be a little more disruptive. A few of them may even be less disruptive than the previous one. Okay? So, they're not the same. No more gigantic releases ever. So if I was trying to do a little clickbait article, I would call it Java 9, the last major release ever. And then I would explain all of this. Keeping up with the features, just, like with the combination, with just feature releases is going to be easier than trying to keep up with that combo of major and minors. We continue to value and pursue backward compatibility, but that doesn't mean that we're never going to change anything. If needed, we will, with proper warning. And if for some reason you cannot stand the change, the LTS releases do afford you enough time to have your program either die on that LTS release. Most programs don't live, 8, 9 years in production. Or, you'll have plenty of time to migrate without having to do so on a particular date, 6 months from release of the next version. Now, late binding of features. Remember when I said we had these plans, JDK 9 was going to come out, it was going to have Jigsaw, and then it got delayed. Most of you are developers. You know that if you predetermine the features, the schedule becomes flexible. If we're going to predetermine the schedule, we cannot at the same time predetermine the features. So, what feature will be available in JDK 14? I have no idea. Okay, it would be my job to know. I'm the product manager for this thing. I do not know. Why is that? Because I can tell you which things we're working on. So that gives me an idea as to what could make it into 14. But until we're closer to that release, I don't know what will be ready and what will not. So there'll be something, certainly, but don't ask me ahead of time. I can tell you what's going to come out on 12, because it's only a few weeks ago. And I have a pretty idea of a couple of things that might make it to 13. Not yet. JDK 9, released in September 2017. GA build, 181. So we took 181 builds to produce the GA version. 100 plus features. Look at the schedule. Look at the time, well, if you can read it, that's unreadable. Feature complete, 2016, December, September. All of that time between feature complete and release was, test stabilization, all that good stuff. And the number of features doesn't fit in one, right? I have to scroll up. JDK 10 in comparison. 10 JEPs instead of 100, right? Look at the schedule. And the GA build 46, shrunk a little bit. It gets even better in the next ones. This is mostly the stuff that wasn't quite ready for 9. And we were okay pushing it because we knew 10 was coming right after that. JDK 11, 17 JEPs. One of my favorite examples, TLS 1.3, the more modern encryption algorithms, so when you connect to a website, you know that you're doing. The RFC for TLS 1.3 was approved in August of 2018. And look at that. We have a release of Java that supports a new TLS only a month after that. I mean, that's sheer luck. But my point is, even if it hadn't been like that, you would have had to wait another 6 months. Now, guess what would have happened if we had a new TLS update, say 6 months before the release of JDK 9? You saw when we reached feature complete, right? About 9 months before. So we would have said, that's great, we'll put it in the next major. So 6 months to go to the next one, plus another 2 years, you'll get it in about 3 years. Now, this is what we mean with nimble, right? Doesn't mean that we can do gigantic things pretty quickly, but when they're ready, they come out. And that also means that if we decide, change in priorities we should be doing in this other project, that other project could come out much sooner, right? So GA build 28, and we have JDK 12 due out later this month with the first preview feature, switch expressions. I'll explain what a preview feature is and how it matches with what we're doing now. Are we on time? We're at 20 minutes. Good. JDK 13, by the way. Look at the JEPs. No JEPs. No schedule. Why? Too soon. Too soon? This is coming out in September, right? In the old world, I would have had a nice deck presenting all of the features. I don't even try now, okay? So if you keep an eye on this page, I expect that sometime in the next couple of weeks, you may see one JEP being targeted for 13. And you come back a little later, a couple more. We may end up with 3, 4, 10. But this is what the JDK 12 page looked right before 11 released. So that's the new model. I'm sorry.
If a JEP appears in this page, is it guaranteed to make it to 13?
Okay.
Or even that is not guaranteed?
The question is, if a JEP appears on this page, does that mean it's guaranteed to come out? If you look at the older version of JDK 12, you will see that there was another preview feature called raw string literals, which went into the JEP and then came out. So it is unlikely, but we're not playing games anymore. You're all adults, so we will tell you what we think is coming in. We will not withhold something until we're ready, but there's always the chance that something will come out. Mind you, it was tagged as a preview, so we knew it was still iffy. So it is unlikely, but it could happen. Unlike the previous model, by the way. So, as I said, now we have more rapid cadence. What does that mean? I remember that I said a bunch of things broke with JDK 9. Why did they break? Anybody here has tried to move their application from JDK 8 to past JDK 8, rather than writing a new one? So those people that raised their hands when I asked who's using 11. New application or migrated from an old one? Any migrated? Okay, what was the big deal about migrating to 11? Did you have to rewrite a lot?
Actually, like some of the methods of the preference cluster at the system level, so that's now private, so that's a major challenge.
Right, there were some major challenges. Let me tell you what the other challenge was probably. You had to update your third-party dependencies. That's the most common case. And here's why. JDK 9 introduced some level of encapsulation. It's not fully turned on by default, but some internal classes that were meant to be used by the JDK to provide support for the officially supported classes were labeled as do not use. I can show you a 1995 warning from Sun saying don't use the APIs on the SAN package. Okay? When we were migrating and we said we're going to close those, they're not going to be available to you anymore. But before we do that, let's take a look at all of the source code out there. We can see the open repositories much like anybody. And let's see how many people are actually using those APIs. Who thinks it was about 50%? 70%? What percentage of projects did you think use those internal APIs? 50? How much? 100%. Every single one of them. How can that be? How is everybody so careless? It's not that you're careless, it's that you use some common libraries. And those common libraries use this. So, if log4j uses, then everybody that uses log4j suddenly has this problem. And the problem with this is then, what I'm trying to illustrate is when you grab a library, you're grabbing along all of their decisions. If they decided to use internal APIs, you're now using internal APIs. If they're using deprecated APIs, you are now using deprecated APIs. And in some cases, you cannot even tell because you don't have the source code, right? So, JDeps. It's a tool that will scan the bytecode. That's the library that you download. It'll tell you which APIs it's using, and it'll flag if it's using some APIs that are marked as internal do not use. Okay? Next one. JDeperscan. What if I'm using a deprecated API? Right? Well, at compile time, I get a warning. But at runtime? And again, what if I didn't compile it? It's just a library, I just downloaded it. I can use JDeperscan to find whether a library is using deprecated APIs. And we made it more interesting. What is a deprecated API? Right? What's going to happen with a deprecated API? Anybody? It's going to be removed, right? Maybe. We use the deprecated annotation to mean things like, this is a bad API, we're going to remove it. Or, there's nothing wrong with this API, but there's a better one. So if you're writing new code, you never want to see deprecated APIs. But if there's some legacy application that you're not actually maintaining and you just want to know if it's going to run on the next one, deprecated APIs in the first category are likely to break it. Deprecated APIs in the second category, right? That's okay. So with JDK 9, we introduced an annotation, which is for removal. So when we deprecate something, we also put a little annotation saying for removal equals true if we plan to take it down. So those are especially bad for your code. The tool allows you to find the use of deprecated APIs, and you can pass it a flag and say, don't tell me about all of them, just warn me about the for removal equals true. So if you run this tool, it'll tell you ahead of time, is your program likely to break on the next iteration? Okay? So that's what I meant. If you start skipping releases, you may not notice that one of the updates introduces that warning, and you'll only discover when you try to update and it blows up in your face. Incubator modules. So like, we have to drop stuff. The other part of trying to keep it stable is don't add anything that isn't ready. Now, having shorter release cycles makes it easier for us because we don't have to rush anything. If it's not quite ready, come on, in 6 more months, we'll get it ready, don't worry. We don't push it in. But there's certain things that you cannot make ready unless you put it out and have people test it. So in some cases, we want you to test them. We want developers to play with this, but we want system administrators to be wary of those. Okay, so it's okay if you're playing with your little sandbox thing and you're trying something out, use these new methods. So we figured, okay, let's put them in the Incubator module. The Incubator module is not enabled by default. You have to turn it on. So as a developer, you can play with something new before it's really, solid. But as a system administrator, if I see an application that, to start this application, please turn on Incubator Modules, I'd be like, no, thank you. That application may not update to the next version, and I don't want to play with that game. Likewise, preview features. So Incubator Modules works pretty well for an API, but what about a language feature, a new language construct? That's not in a module. So we've introduced with JDK 12 a new concept, preview feature. This is 99% ready, but we need more feedback. JDK 12 not only, theoretically says this is available, it introduces the first one. There's something called switch expressions, JDK 12. It's a preview feature. You have to pass a command line to compile with it, and you have to pass a command line to run with it. So nobody's going to sneak it past you that their library is using preview features and might not work in the next version. Okay? So, part of the description is I was going to tell you what's coming in the next releases. But we never know, right? What I can tell you is what projects we're working on. So, we continue to develop in OpenJDK. These are the interesting projects. We're moving to a world with containers. We want predictability. We want to increase performance, especially memory management. Java has spent over 2 decades now optimizing how code works. So it produces very optimal code, but the layout in memory, not so optimal. We have then a bunch of projects that we're working on. Panama, Portola, Valhalla. Anybody knows any of these? Okay, let me give you a quick overview. These are the most interesting ones. And all of them have a page in openjdk.java.net, so you can go and take a look at what's going on. Portola. Alpine Linux, anybody knows what it is? So if you use Docker, you'll discover that you'll try to get images of Linux that are as small as possible. But the Linux runtime itself tends to be a bit big, so somebody came up with a much smaller Linux runtime using something called Muscle C library. And Portola is trying to allow for that. So, if you want it in simple words, this is porting Java so that it runs on Alpine Linux, which is the preferred operating system when you're running on containers. Okay? Project Valhalla. This is called value types. You write a class like that, right? It's just data. It's just a container for data. It doesn't do anything fancy. Now, Java says that anything that's not a value type is an object. And as an object, it has identity. And if it has identity, it needs a header, And therefore, if you want an array of these guys, you need a header, which is one word, and then even though you only have 2 data points, for each one of those you need a header. And what's more interesting, when you have garbage collection, you think this is all nicely aligned, but every garbage collection will reshuffle these in the heap. And that means that when you're doing some prefetch for memory and you're trying to keep your processors fed, you're going to have a bunch of cache misses, right? And that is required for objects that have identity. Now, what happens if I do not need identity, right? I'm going to compare the objects just on its value. We would like you to be able to write something like the value class data point. And when you do that, we want to put it in memory, flatten them up, and allow you to take advantage of how modern computers work. These will be much more efficient. We're reading this data from memory. You pay a penalty for these, in the sense that that new point doesn't have identity. So you have to figure out how you work with nulls, and you cannot ask, is this the same as? You can only ask, are they the same value, right? But most data classes, you didn't need identity anyways, so if you're willing to give up some of the flexibility, we will reward you with better memory management and better performance. Project Panama. Anybody here has written a Java application that interacts with a C program or uses a C library? Anybody? No? One person? Two? My apologies. Because the interaction between Java and native code is significantly harder than it should be. Okay, it was not just an idea, let's try to, it's not that they didn't try to make it easy, they didn't mind if it was hard. Which was fine, back when Java was coming up, everybody thought Java, you should never go anywhere outside. But in the real world, you have a lot of uses on which you actually need native integration. So Project Panama, think of it as a replacement for JNI. Okay? Project Loom. Anybody here programs, creates concurrent applications using threads? You do? How easy are those to read and debug and understand, and how costly are threads? You have a program, you're going to create a handful of threads because they tend to get pricey. Project Loom tries to create something called fibers, which is the equivalent of threads, but rather than having them be operating system level, they're now managed by the Java runtime. When you do this, they're basically free. So the goal of this is to allow you to write concurrent applications that look very much like the sequential applications that we all know and love, right? So it's trying to make it possible to leverage concurrency without having to go through all these, like mental shifting model used nowadays to create concurrent applications. There's some really nice demos of these. If you look at the Oracle code of last year, 2018, the keynote by Mark Reinhold, the Java architect. Take a look at that. Project Amber. This is mostly, we know there's a few pain points that are relatively simple to fix. And this is one example, switch expressions. We use the case construct a lot to create the equivalent of a method, right? Int, let's find how many number of days are in a particular day of the week. Number of letters. So Monday, Friday, and Saturday, 6. Break, 7. Break. Forget the break, you know what happens, right? You have to handle it with the default at the end and all of that good stuff. And really what you wanted to write was something like this, right? It's a function that uses a case statement. That's a preview feature with JDK 12. So if you turn it on, you can write that, okay? We've already delivered local variable type inference, JDK 10, and this is coming up, local variable, the syntax for local variable types for Lambda expressions. So there's another interesting thing here. Notice that this is one project, and I'm talking about it already delivered things in 10 and 11, some things in 12 and in the future. So there is no one-to-one equivalency. A project will father many different improvements that will go into many releases. Okay? Here's another one, raw string literals. Who has written code like this when you try to embed some text, right? And you have to escape the carriage return, and you put your double quotes, and you concatenate with a plus. How about this? Right? This is a backtick. Then everything between backticks is just as is. Page breaks, carriage returns, everything. These are equivalent. You don't suffer from the leaning toothpick syndrome where your applications have to escape everything. This is very useful, for example, when you're doing regular expressions and you want to put, like, you always had to escape those leanings, so you ended up with these little constructions that look like little houses in your string. Much more comfortable to write it this way. Again, relatively simple, but eases some common pain points. And Project Scara. Anybody here works on OpenJDK? So when I talk to developers, I always, in my mind, have them as you're either a Java user, but you don't care about, how Java is built. Or you're an OpenJDK developer, and then you really care about this. So this is to move the source code that is being used in OpenJDK from Mercurial to something like Git. Okay? So most developers will probably not see anything because the end result will not see the effect. But we hope that this will encourage more people to raise their hand next time I ask who here is an OpenJDK developer, because they'll be more familiar. Okay? Now, how am I going to test these early access features, right? We used to have early access for the next major release for a long time, and that's how you tested the new functionality. Now what we have is an early access for the next releases. We still have ready for use 11, 13 and 12, you can already get them. And in some cases, not for every project, we have here, Panama. If you want to talk about that JNI change. This is what's coming out of Valhalla, this is the value types. It's Java Mission Control, OpenJavaFX, JPackage, a tool for creating an application that looks like a native application. You write a Java application, and it ends up looking like an exe for Windows, or a DMG for Mac OS, or like executable RPM for Linux. And we have the reference implementations. So go take a look. Some people say, well, 6 months, too little. We have a pretty good track record of having the early access of the next release be pretty much the final thing about a month before GA. So if you have been playing with the early access of JDK 11, you will notice that the build number that we made as early access a month before GA was the same build number that we used for GA. Same for 10. So you don't have to wait for a next feature release to GA to try it. We welcome feedback on this one, and we need it, especially in the projects that are coming out. Okay, so I hope that gave you an idea of how we're dealing with this new release model, and that it's not as scary anymore as some people will get from reading blogs explaining how horrible everything will be and how everything will break. We don't hope for that. In short, we're being even more open. Welcome contribution, welcome information, welcome feedback. If you have questions about the project, you can go to the project page. I would strongly recommend that before you start sending emails asking questions, you read the archives, because there's nothing more annoying than getting an email asking a question that was answered 2 weeks ago. Once you join, please come ask questions. JDK 11, the first LTS, we have some major performance improvements, productivity, and in case you're interested in getting the long-term support, we now have a subscription offering. It used to be if you wanted to buy a Java SE contract, you had to go and talk to a salesperson and get an agreement and negotiate price. Now you go to a website, you swipe your credit card, and you get your subscription. Okay? And we have a very solid technical roadmap, but please don't ask me to come and present the product roadmap, because the product roadmap is a release every 6 months with the features that are ready by then. Okay? And I think we have like 1.5 minutes for questions if there's any.
How these fibers and continuations are different
how are Kotlin continuations different from fibers? Sorry, stop me on that one. Yeah, but do take a look at project Loom.
I'm part of the Eclipse compiler team, and this release kind of new one has put us in a lot of trouble. Obvious reasons, right? So we cannot really predict what's going to come in the next release.
Mm-hmm.
So you spoke about the rostering letters, and we have put a lot of effort, and then we have to back out in the last minute because we decided to do more.
Okay, so the point is, you're saying you're part of the Eclipse compiler team, which, by the way, is a special animal because you do have to be much further ahead than anybody else. And that you said that removal of the rostering literals caused you to have to backtrack.
The question I have is, apart from signing up for the bugs and the mailing list, what are the channels that we should be listening to?
So the question is, if you want to be aware of these changes, how do I check it out? Mostly JDK Dev, the main list for OpenJDK. That's where we make the big announcements. So whenever a JEP is proposed to target or proposed to be removed, which was the case of that one, it'll go to the JDK Dev mailing list. That and the early access builds. That's pretty much it. Okay? Any other questions? The question is, WebStart is no longer, WebStart is one of those technologies that I said will sunset with JDK 8. Do you have a suggestion to use something instead of WebStart? So for those that are unaware, WebStart is a way of distributing your application through the web browser. Now with JDK 9 and above, you can create a self-contained application. In some cases, you can just distribute the jar, and you'll have to figure that one out yourself. But the model on which WebStart was based is a 20-year-old model, which nowadays has been superseded by the deployment model changing to using containerized applications and App Store-like deployment mechanisms. So you'll probably have to convert. I mean, converting the application should be trivial, but then you basically have to rely on the distribution mechanism that you use for any other application rather than assuming that Java will help you with that. So sorry about that. Blame progress. No more questions?
Since you moved to a 6-month long major release, so what happens if I find the security issues after I take a major version? Do I have to wait for 6 months?
Okay, so the question is, you moved to 6 months for major releases, feature releases. There's no major releases. Do I have to wait for 6 months? Every release is just that release, and then you have critical patch updates. So the model for Oracle is we produce a critical patch update every 3 months. So for example, 12 comes out in March. The next critical patch update will produce 12.01 in April. Then we'll have 12.02 in July. And then we'll have 13 in September. And then 13.01 in October, and so on and so forth. So the result of this is, do the math. Every release every 6 months, 4 months, it's major, 2 critical patch updates, next major. So if you find a security vulnerability and report it, we will strive to fix it in the next critical patch update, and then all releases after that one should continue to have the fix. Does that answer your question? Thank you. Any more? Thank you. In that case, stay where you are. I'm taking a selfie. So you can find yourselves in Twitter. Now, let's see if this works. Say hi. Thank you, guys. You've been great.